Hi there, and welcome to part 2 of the knurling tool project. If you just discovered this on this part 2, part 1 is actually under the heading Shed Talk 14. I had various other stuff going on, but this is purely about the knurling tool, so this will come up as something like making a shop-made knurling tool part 2. But anyway, if you just joined me, you're very much welcome, and if you're a regular, welcome back, guys. Comment came up on the part 1. I mentioned in there about changing the nuts and washers that hold my chucks on for a flange nut. I was not a serrated one, I was going to put smooth ones in. And somebody commented that, you know, it defeats the purpose. There's no washer there to stop rotating that damage in the back of what is, in this case, the back of the faceplate of my lathe itself. And very good point taken on board. I don't know what I was thinking there. It was just, sometimes I just think out loud as I'm going along. But anyway, yeah, point taken. Somebody else commented that I could put some little knurled washers, do a little bit of adaptation to make it easier to get in. I'll show you what I mean. So as you can see, between the back plate, the rear plate here is the headstock of the lathe itself, and the main body, then there's very little room. It's only actually about 15 mil, of which sort of 7 or 8 mil is taken up by the nuts and washers. That's what I was thinking, because it's very difficult to get these, fiddly getting in here, and you've almost got to do it as you go along, sort of just start them all and then gradually pull it back and what have you when you're putting it on. So yeah, I think what I'll do is make up some, somebody commented this again, some slightly thicker washers, maybe with a knurl on the outside, something I can grab hold of. I can certainly have a couple of extra mil, because the threads are they're sticking out a few more mil, so I could literally double up on the thickness of these washers and then replace with, maybe I'll get some stainless nuts, something like that. But anyway, so just thought I'd address that one. So I forget the name of the guy that commented, but yeah, taken on board. Right, I'll move straight on. I centre pop the block where I want where I'm going to bore a hole. And I've got my pin here, which is basically just picks up on the centre pop, and the other end, it's, let me come out a little bit, you can see it's on my centre, it's centre drilled the other end, and it's a ground rod. So yeah, I'm simply going to clock this in. Let me see if I can get you a better picture again. Let's come out a bit, there we are. So yeah, so let's have a look. That's a high point there, that's a low point, just lower that one. Come on to this end, a little bit of a squeeze. Let's have another look. We're getting close. That's low, that's high. Might get a couple more thou out of there yet. That's a little low there, and that's the high one. I think for the purposes of this, I could spend another couple of minutes getting it running bob on, but this is roughing out, so not too worried. There we are. As you can see, the needle's not moving now, and I've clocked in the centre pop. I think I've shown this before, but I'm not sure, so I just thought I'd share that with you. And let's just bring this out. And basically I've got a ground rod here, a centre drilled and machined taper in that end. And that end is a machine taper as well. It was clocked up perfectly and machined. So when I put the point in a centre pop and the centre on the other end, basically if I had my centre pop out, it would be wobbling around like this sort of thing. And that enables me to clock in a little centre dot. Anyway, I'm going to get on and bore this hole out. So I've just got a slot cutter in here. Blind drilling it, and I'm going to go to 6.5 mil deep, which should be there. It's an old one. I'm not worried about the end of the slot cutter, but I've just gone 6.5 mil deep just to take the root out. I've just pulled the tailstock off the lathe. Now this is as fast as I can go, 450 RPM. I should be doing double that, but well, I'll actually show you the problem. I don't know whether it'll show up. Can you hear that? That's no good at all. The whole lathe is shaking around. $460, and that's the offset weight. Obviously I've got a load of weight hanging out this side and not so much that side. and if I spin it up fast it's way out of balance, and giving it all this doesn't do anything any good. So I keep it to a point where it doesn't bother it. Obviously on a bigger lathe wouldn't cause a problem at all. So I'm just facing out the bottom of this to a diameter. I'm going to go about 26 mil and see where that is. Again, I'm not worried. That's measuring 25. I know I got a mil in there at the end, so let's just give myself a 0. I'm purely concerned with removing material. I'm just coming in from the back to take the time out of the job, really, so that the milling cutter hasn't got so much to do when I'm on the milling slide. You get the idea. I'll just keep placing it out, you know, like half mil at a time. This may seem a slow process, but I can assure you it's a lot quicker than, for roughing this out, it's a lot quicker than milling it would be. Well, here we are. I've bored it 6.5 mil deep from the base, and I've done it just a rule size 26 millimeters diameter. So that's taken out a great big chunk of the material and saved a bit of milling. Okay, so I've set the job up in the milling fixture, in my milling slide, in the vastly oversized vise, but at least I know it is tight. It's on some parallels, so I know it's vertical in this plane. I can doctor that should I have to. I mean, I could clock it up and down, that sort of thing, but I know it sits pretty darn good. I do have the facility to machine angles with my milling slide. It can rotate on a spinning boss. I'm sure those of you that follow me will have seen that before. So what I want to do, I'll actually, excuse me picking the camera up, bit of bad planning there on my side, right? Okay, so what I'm going to do is, if I can just get in, I can, as you can imagine, swivel it around against the face of my headstock there. Just hold it with some hand pressure. I'll just nip up the 2 screws. I'm just going to tighten them. I have forgotten to tighten these before now, and unless I dog them down, as it were, I'm going to go mental on it, but let me just check. Looks good for parallel and looks good alignment that way. Okay, so that's, other than the vertical alignment and how much they come in and out of a cutter, that's it set up square to the axis of the lathe. I've got a 12mm cutter, metric 12mm, up in my 12mm collet here, which is an MT3, goes up the spindle. I clean the spindle first. As you can see, I'd like to put that cutter a lot further in, but it doesn't physically fit any deeper into that collet. The 10mm ones will go through further in the 10mm ones, but the 12s won't. So I can't really help the rigidity by bringing the cutter further back. So I just tighten up the drawbar there, everything's back, and we're ready and set up with the cutter and the headstock. Okay, so those of you that follow my channel for some time will have seen me do all this before. So I'm not going to show this in full detail. If you look back and you haven't seen this before, look back at my series on making my quick change tool post. The full details of me machining the dovetail will be there. I'm just going to show the first couple of cuts of this, opening out the pocket, skip through that, and then go on to cutting the dovetail itself, rather than showing it in the normal sort of detail that I generally do, because regular viewers will have seen it all before. Okay, what I tend to do is set my carriage lock here, which is locked onto the bed, which stops me being able to advance my carriage. I know I'm going 7mm deep, so I've allowed myself enough adjustment, and I simply adjust my cut depth. I can do it here. I'll look at my DRO on its previous cut. and I'll just adjust forward until I get my cut. In this case that's 1/4 mil. Lock my carriage, start the cutter up, and if I can find it, excuse me getting in shot a minute, I'll put a little bit of cutting compound on there. Oop. I'll bring you in a bit closer. I want to take you out of the shot and proceed to take the cut. Now sometimes, I don't know if it's visible under there, the rattling noise is the handle on my milling head. In fact, that was a lot bigger cut than I was planning. That was more like 1 millimetre in one pass, I think. But you get the picture. I'll keep passing this through. I'll take it to depth. Well, I'll rough it first. I'll take it to a depth of 6.5 mil. Then I'll gradually adjust vertically. I think that cut is a bit blunt. We'll have a look at that. Anyway, I'll gradually adjust upwards until I get the desired dimension between the bottom and the shoulder, and then I'll drop downwards and open up the slot width to machine the top face, and then I'll look at finishing it all with a dovetail cutter. So to get my bottom shoulder right, I need to raise the head up by 5 thou. So on the needle I got a clock on top. There we are, 5 thou. That should be my finishing cut of the roughing out part. So I'm probably 35 minutes I think down the track, and I've finally got that roughed out. Now when I say roughed out, I've actually machined the slot 7 mil deep, which is a theoretical finish size, and I've done it to 27, and in fact I pre-checked it again, and instead of 27.5 it's 27.3 wide the slot, and obviously the distance from the bottom face to the bottom of the slot is correct as to the nominal, which is let me just have a look. I did write it down somewhere on a sheet of paper. I did a bit of rough calculation if I could find it. What did I do with that? I'm forever putting things down here and thinking, right, where did I put that? Oh, there it is, it's fallen on the floor. Yeah, I worked it out. It was 30 mil to the centre, half of 27.5, 16.25, so that's 16.25. It's not that fussy, to be honest, because the back edge of the tool doesn't do anything. And the overall width of the slot, 27.3. The last sort of mil and a half of these two faces is finished, because that will leave the little flat on the top for when I put the taper in, because you don't want it to taper into a sharp edge. Okay, so that said, next thing to do is get the dovetail cutter up. So I've got my dovetail cutter up. Good news is that it does sit a lot further back against the headstock. Bad news is you won't be able to see a lot. I've set my stop. I am going to take a skim off this face, of the outer face that rests against the tool post, and I'm going to skim this face at the top as well to the same dimension, just to basically quantify that this space is in exactly the same plane as the face that's going to be machining with the dovetail in. Just something, it probably doesn't need doing. I normally find that it's a thou maybe across the faces, which makes no difference in the long run, but I do like to do it, just it gives me a reference to work off. And also when I've skimmed it, I can zero my DRO, and then I know I've got to go 7 mil from there. So I'm going to get on with that. As I said earlier, if you want to see me cutting dovetails, go back and have a look at the Quick Change Tool Post series, and you'll see it there. So I'm going to cut the dovetail in here in exactly the same way as I did with those. So it probably took me, all in all, about an hour to do that. So, yeah, I mean, the dovetail's finished. Drop it on. It locks off. Open the lock. I probably could have eased it a little more. And it locks off simply with my lock. happy. I run a stone over the edges. Oh, I keep saying a stone. I have run a stone over the surfaces and what have you to take off any high spots. Removed all the corners, filed it, that sort of thing. So, now we have a block. We'll worry about the height at a later date. I think what we need now is, let me just come out a bit. We're going to have the scissors. How are they going to go? This sort of way, one on the top, one on the bottom. Top and bottom are here on the overhang from the tool post, you know, when it's in its position in this sort of area. So I think what we're going to need is a slot down through here for the fingers to insert into, which will later have pivot pins top and bottom here. Now I can't see me having to knurl anything much over, I don't know, probably about 50mm maximum, but probably 30 is more like it. But the 50mm, as long as they'll open wide enough, and you know they're going to be this sort of length. Don't want to go too far out, but yeah, they'll probably be 50mm long arms, something like that. So they should open up to, you know, the sort of running position will be sort of 25mm, something like that, and they should open up bigger should I need them to. So the thickness of this, as it stands at the moment, is, could have sworn it was thicker than that. Hold on a second. Yeah, 24.6. So I'm thinking if I put a slot down the middle, leaving a wall of 6mm either side, that'll be like 12.6. If I'm using a 12mm cutter, I'll aim at 12.5mm down the centre, and if it works out at 12.6, then obviously I can just machine the arms to suit so they're not flopping around, so to speak. So my next procedure is going to be a 12mm slot, or 12mm cutter, run a slot down through the middle of there, and it's going to end up sort of 12.5. I'll have to lift up and down on the on my milling attachment to do the slot. I've squared the part up, blocked it up, got it all sorted, everything's level on the top face here, so, and I've squared it up that way in this plane to the headstock again. I've marked a centre line on the end, and what I need to do is to take my initial cut is to get it at centre height. Now, rather than take this off and, you know, get a chuck out, get a centre finder, all the rest of it, and, you know, pick up on both edges, that sort of thing. I mean, you know, it doesn't have to be smack on the centre. I mean, I'm going to be adjusting the cut top and bottom, so I've got an equal thickness either side for the slot that I want. So it's not critical, but I just like to put my 12mm slot, or 12.5 is going to end up, started in the centre, and then I can work up and down at the end. Right, so I'll show you a little trick. So what we need is a packet of blue tack, white tack, whatever, you know the sort of stuff for all sorts of makers, and a pin. Ideally you want one of the pins with like a, you know, like a, not a drawing pin, but this is a notice board pin, but one of the ones with like a bobble end, just like a ball end and a pin. So what we're going to do is take ourselves a chunk of blue tack. In fact, because I got the wrong pin, I'm going to need a bigger bit. Bear with me. Roll a little ball, and I'm going to sink that pin into the blue tack like so. There we are, so I got plenty of meat on the end. Then I'm going to clean the swarf off the end of my milling cutter. Hang on, let me just check that we're in shot here. Yeah, you can see the end of my cutter. And I'm going to push the plasticine would do the same job, but blue tack seems the most sort of effective for this, and get that somewhere near centre. In fact, this pin's working out quite nicely. Okay, so I'll just start the cutter up. Now then, I'm not going to use my fingers for this. I'm going to use an object. It's just first thing that came to hand is a needle file. A bit faster, eh? There we are. At the end of that pin, nearest damn it, is running true. So I can bring the job up. I'm going to try and keep out the shot here. And I can align my centre line with the centre of rotation, which theoretically, I'm going to have to get in shot. I do apologise. So you're sure you've got a lovely view of the back of my bald head. And there we are. I don't know how good I can get in on this. Let's see. Now, lose focus if I get that close. I haven't got a macro lens. But the centre line of the job is, you know, probably within a couple of thou, lined up on the centre. Just slight wobble coming in on the tip of the pin. Up a tiny bit, so or so. Right. So there we pretty much have it. The centre line is lined up on the end of the spindle. So it means I can run the cut through here now, and I know I'm pretty much central about. An old trick taught to me by a couple of old tool makers in a tool room. Probably second year of my apprenticeship, something like that. We call it a sticky pin. Gets you out of trouble when you're stuck, and when you don't have to be critically accurate with edge finding, that sort of thing. So I'm going to touch off, set 0 on my DRO, and go into my depth. I'm going to have to take it very gently again because the distance away from my milling slide, it's stuck out a country mile. And again, the 12mm cutter stuck out a country mile, or for my metric friends, a country kilometre. Anyway, so I'm going to touch off and start milling a slot through this way. I've got my vertical slide locked, and I'm just going to gradually work my way in. I've got my lock down here. Can I get you there? Yeah, I got my lock set, just off touch off, and I'll wind myself in and probably do, I don't know, 0.2 at a time, see how that goes, maybe 0.3, see how it goes. I might show you the first cut, and then I'll carry on with it and bring you back when I'm done. And I might... Well, that was a half-mil cut. I think I was a bit keen, especially with the way things are stuck out as far as they are. So I think we'll drop back to like 10 plough cuts, I think. So this could take some time again. Well, that whole setup was of questionable parentage, shall we say, and the bugger jumped out the vice on me. Well, actually the cutter caught breaking through the end and jumped, but never mind, that's why I made it longer than it needed to be. So I'll remachine the end back flat and come up with a different setup. Never one to be beaten. I will not be beaten. I will not be beaten. I will not be beaten. Note to self, I will not be beaten. I will not be beaten. Couple of M8 tap holes through my little sub plate. Bit mean with that one. Okay, M8 6.8. Gotta take it easy, there's not much guts in that drill. My goodness. I'm just looking, hang on, I'll show you guys, bear with me. That isn't half of it. Look at that lot. I think we're going to call it a day on this video. I'm going to have a real good tidy up because I can't work in this. It's just, there's stuff everywhere. I do have a cunning plan to be able to machine that slot. And we'll probably bring you back in part 3. Well, there you are. I had a bit of a crash. I don't mind showing it on the channel. The job moved. As I said earlier, the part was stuck out a country mile or a country kilometre for the metric guys. And the tool was stuck out a mile as well. And all that flexibility, something was bound to give. I did try, you know, tickling it across, but I was asking for trouble the whole way. So anyway, it leaves me with a problem. But no such thing as a problem, really. A problem is only an opportunity to find a solution. You know, and as engineers, finding solutions is the name of the game, really. Solutions to any problem. Well, not any problem, but you know what I mean. Engineering problems. So I've drilled a couple of holes in my base plate of my milling slide. Ready to take M8. I won't reveal the solution this time. I shall show you the solution that I've come up with in part 3. So anyway, thanks for watching, guys. Thanks for subscribing, and we'll see you all very soon.